Cosmic Brief, your guide to the universe.
What if Earth's magnetic field suddenly disappeared? Our planet is wrapped in an invisible protective bubble called the magnetosphere. It is generated by powerful electric currents deep inside Earth's liquid outer core. As molten iron moves and circulates, it creates a global magnetic field that extends far into space. This magnetic shield acts like a deflector. It pushes away most of the charged particles constantly streaming from the sun, a flow known as solar wind. Right now, that shield is working every second. Without it, Earth would be directly exposed to high-energy particles from space. If the magnetic field suddenly vanished, the first effects would appear above the atmosphere. Solar wind particles would no longer be redirected around the planet. Instead, they would strike the upper atmosphere directly and continuously. Radiation levels in near-Earth space would rise sharply. Satellites would be the first systems at risk. Increased particle exposure damages electronics, corrupts memory, and degrades sensors. Navigation satellites could lose accuracy. Communication satellites could fail prematurely. Some spacecraft might shut down entirely. Next comes atmospheric response. Charged particle collisions would increase ionization in the upper layers of the atmosphere. This heating effect would cause those layers to expand outward. When the atmosphere expands, low-orbit satellites experience more drag. Their orbits decay faster. Station-keeping fuel would run out sooner. Auroras would change dramatically. Today, auroras appear mostly near the poles because magnetic field lines guide particles there. Without a global magnetic structure, auroral activity could spread across much wider latitudes. The night sky might glow with frequent radiation-driven light storms across many regions of the world. Now consider aviation. At high altitudes, aircraft are already exposed to higher radiation than at ground level. Without magnetic shielding, polar and high-altitude routes would see increased exposure. Airlines might need to reroute flights and reduce altitude to protect crews and passengers. Then there is the electrical grid. We already know that solar storms can induce electrical currents in long conductors like power lines and pipelines. These are called geomagnetically induced currents. They can overload transformers and destabilize grid networks. Without a magnetic shield, particle flow disturbances would be more frequent and more intense. Grid stress events could increase. Transformer damage could become more common. Regional blackouts might happen more often during strong solar activity. Would humans on the surface be instantly harmed? Not immediately. Earth's thick atmosphere still blocks a large portion of incoming radiation. Surface life would remain largely protected in the short term, but long-term exposure risk would increase, especially for people at high altitude and high latitude. There are also biological effects to consider. Many animals use magnetic sensing to navigate. Birds, sea turtles, and even some bacteria. A missing or chaotic magnetic field could disrupt migration patterns and orientation behavior across multiple species. Navigation systems would change too. Compasses would become useless. Any technology relying on magnetic reference would need replacement methods. Surveying and directional tools would shift entirely to satellite and inertial systems. Over very long timescales, there is an atmospheric concern. Magnetic shielding helps reduce atmospheric stripping by solar wind. Mars lost most of its magnetic field billions of years ago, and over time, much of its atmosphere escaped into space. Earth would not lose its atmosphere quickly. but the protective effect would be reduced. It is important to understand that Earth's magnetic field has reversed polarity many times in geological history. North and south have flipped before, but these reversals happen gradually, not instantly, and the field does not drop to zero everywhere at once. A sudden total disappearance is extremely unlikely based on current geophysics. Still, this scenario reveals something important. Our technological civilization depends on invisible planetary defenses. Magnetism is not just a curiosity, it is infrastructure at a planetary scale. We are protected not only by air and distance, but by a dynamic magnetic engine beneath our feet. If that shield were gone, the sky would change, space would feel closer, and our technology would feel the stress first. Which would worry you more? Radiation exposure, satellite failure, or power grid collapse?